Hey everyone, welcome to my next video. It's been a while, but I had school and I'm all done and holidays are here. But instead of just going to the seaside, I'm working at a company as an intern student and it's pretty dope, and I'm working with embedded processing and other hardware, and it's all fun. And in the nature of working there, I decided to make another video as an update or a part 2 or a version 2 of my first video that just surpassed 1000 views, so that's amazing. And so this is gonna be a version 2 because we're gonna handle our debugging, which is a very important thing for all those who made big project or working at a company for their products. So for those who are familiar with my videos, you might find this very familiar. We have our editor, in this case Atom, and I have all the libraries on my left and the code and our free function that we have used. Mostly the first one, which is the st-flash, which we used to upload the code to our processor using that open source st-flash utility from GitHub. Everything about that you can find in our previous videos or on my GitHub repository. But that's how we worked. We edited the code, maybe used usart or uart with R232 converter to send some debugging code to our computer, so we saw that the road ran fine. But that isn't very good if you're working with big projects with lot of function, with lot of if-else statements and lots of ways the program can go to make some states. So depending on buttons, driving LEDs, reading data, maybe editing that data to compare it to predetermined arrays. So that is a little bit intensive. So you should use some kind of debugger and an IDE with that. So in that spirit, let's go to our first workspace and I'll introduce you to the system workbench for Linux, especially for the STM32. So this is a large community that's making open source tools for the STM32 development based on Eclipse. And it's very refined by now. It supports lots and lots of processors and debuggers, especially the J-Link and the embedded ST ones. And this is where we're gonna go. This is the best option so far I have found for debugging on Linux, and it's very fine, but we'll have to make some adjustments, but it's very intuitive to use and to install. Very simple. So if we go to the OpenSTM file, we'll open this page, and it'll probably say login or register over here. So you just make an account if you don't have already. I'm already as sausage. And then go to the download instructions over here, and you'll come to this page, and let's bypass Windows because that's not why we're here, and download the latest 64 version or 32 if you have one. Down it's a jar executable. You just download it, execute it as a normal executable, and just follow the steps in the installation wizard, and you have already some other warnings over here. You might read them and some other installation instructions online if you want to know how you can install it. But in my case, I have installed it in the documents folder in its own folder, system workbench, which is it's on the root, and it's over here, the system workbench, and I have all the files here, and in the documents I have my workspaces, but you can put your workspaces anywhere you want, and you can open that one by one and have settings for each. So now let's go, and then you can install it. You'll come to something like this. I have modified the windows to my taste. There's a project explorer on your left, but I kind of wanted to have it hidden, and here I have some variables depending on where you're at, and this is the main IDE. It has lots of features that I haven't even saw already, but the main one will be that your IDE won't look like this. It will have an awful white background and awful syntax highlighting. You won't be able to see anything. Highlighting things, selecting the rows, this will be painful as hell. So it looks like nothing. You'll just want to gouge your eyes out. But luckily you can go to the preferences, or where did you go? you can go to the help and Eclipse Marketplace. After a few hours of trying to edit the syntax coloring, which you can do in the preferences, you can just dig in there and find it for yourself. But then I just thought of this and went to Popular and to see, let's see what's in the Popular tab. And the most popular thing in this Eclipse Marketplace happens to be the darkest theme with DevStyle. And obviously, dark theme, yeah, I installed it right away. And it has loads of instruction, and what this theme does, it edits everything in here. Also it edits the welcome screen and all of that, so it's all dark. It handles the syntax highlighting, which in my opinion is very beautiful and very clear, so you can see your code very well. And this is our new main function that I'll be including in as a template. And as you can see, I don't have the user anymore as a base setting. That's because we have a debugger over here. Let's see the code. You just toggle all the LEDs present on the board, and we have a variable I that we will increment by 15. I also have the delay disabled, as we're going to debug right now, and while debugging, delay is just delay your debugging. So you will want to get them out of your code unless you're running the code natively on your board. And that's all of it. It's just a few delay functions that are handled by the global sysdig timer, and the user button defined, the LEDs defined, the clocks. Oh, the user clock is still here. Let's delete that. We don't need it. And that's it. That's all of the code. And if we go to here, this is the Project Explorer. Let's make a new project, so I'll show you how to come to this. So let's create a new C project. In this case, I'm working with C. You give it a name, something, the default location in your preferred workspace. And then we're gonna make an executable AC STM32 MCU project. Click Next. We're gonna make a debug and a release. So we're gonna have a release bin file for uploading it to the processor and debug file with the ELF and other files for debugging. Let's go next. And then let's select our board. We know it's a discovery board, in our case the STM32 F400. It's an F4 board and it's the 407G Disco. Next, we're gonna use standard peripheral library, and in this case might give you an error, and you can just click to download it and it will download it for this particular processor family for you and already incorporate it, as in this case, as a source in the application project. You can also use the HAL library, which I will try to migrate it to because the people at the company told me it's better, it's faster, and it's more intuitive. So especially when going to harder functions like I2C is very difficult with with the standard peripherals. So in the future episodes we're gonna migrate to the HAL, but because HAL as hardware abstraction layer is a little bit higher but still dealing with lower end functions, it's not a problem if you already know a little bit of the standard peripheral library, which is very down to the writing into the register, as I told in the previous episodes. It's very low level, so if you understand standard peripheral library, you're gonna be able to learn HAL better because you already know the basics and how behind the HAL everything works. After that, you just click finish. I'm not gonna do because this is what happens. You can get this folder structure. Here's the standard peripheral library with source and include files, so this is already familiar to you. We're gonna get the source file, where you usually have all your .c files like main, syscall, and the system file. We have startup files, debug files, the CMSIS folder, which is the one for the course, and the other include files, and here's the linker script and the config file over here. We also have some binaries. This is the ELF, which is the debug file, and any other includes, like for the CMSIS device, and all the libraries are going to be referenced over here in the includes. You can dial that information, but this is working from the beginning. So we have a main file. I noticed that the 407 isn't particularly represented here because, again, if you reference to the previous episode when you dealt with timers, the global timer for the microprocessor was wrong because the input divider of the PLL was configured wrong. So here we have our outline viewer where you can see all the macros and definitions, and oh, this is so nice. You have multiple definitions of PLLM, which is the main divider, which should be at the same megahertz number as the clock frequency of the crystal going to the microprocessor. In our case, it's a 8 megahertz crystal. So, and you can see all of those are they have a line through them, so those are not used in our case. So our define only uses this one, and it just jumps and highlights it to it. This will be at 25 megahertz, I've seen, so correct it to 8 megahertz because the 407 is also defined along with 401 processor family, so it should be the same settings over here. So you just selected 8 megahertz over here, so it will work properly. So it will run a designated frequency. After that, this is all. You can click this, which will build all, or Control B, and this will build everything. And then click play. I call it like that. And this will upload the code to our microcontroller. And in this case, I don't have the delay over here, so my LEDs on the board are just on all the time. That's fine because this is doing very fast. But let's debug it, and we click this bug over here, and it will ask you, but I just selected yes. We will take ourselves to another window. Over here you see there are two kinds of windows, the editing window and the debug window. And in debug window you can have a different composition of your windows. I have usually two windows for code, one for my main function, another for other functions or the libraries. And here I have variables or other watches which can you set up with the expressions. Over here you can watch the registers, you can watch the IO, modules, disabled outlines, everything. And these variables, this will watch the local variables only. And if you want to watch global variables, you go into expression and add the name of the global function or a particular local function that can be used only in some local functions. And it will watch the whole time. And over here we have debug information. So now we're in the debug mode and it has a session already began. It's on the pause right now, and on the left we can see the arrow showing where we are in the code. So this debugging actually stops the processor core, so it stopped, and we can view where the processor has stopped. So this is all the debug information that's going into the SWD lines or the JTAG in some sense, but here it's not. So this is all the debug information going from the processor to the debugger, which is the STIC on the board. So you can see where we are. Also, on each function or line, we can do a double click and we can make a breakpoint. So a breakpoint is a point to where you tell your program where to run to, and when the program comes to that point, it will stop the processor again. So we can go line by line or function by function. In that case, you can click F6, or over here, you can see that step into is F5. If I click F5, it will go to this function and through the function. But you can also use step over, which is gonna execute everything inside this function and go to the next one. So if I click F6, it's gonna go over this function and execute it. So now the processor, the program that we're running is over here. And if I click F5, this will take us into the GPIO setup. If I click F5 again, it will go forward because this is just writing in something. But if I click now F5, it will go to GPIO init function and open our corresponding library where this function is. And we can go through all this and my finger hurt, or I can go back to this line and I can right click and set run to this line. And it will run the program and stop at this line. And now you can just simply click F6 to skip, and now again F6, so we execute this program and go back. F6 again, we're here. F5 if we want to go to this function, but F6 if we want to step over. Also, you can put a breakpoint like this and breakpoint like this and click run or F8 and it will run, and when it hits a breakpoint it automatically pauses. Again F6 and we'll go to this line. Over here pay attention, the variable I, which is a type integer, unsigned integer, 16-bit, has a value of 0. And if we go a line, we go back, and it highlighted because it's changed now to 15, because we add 15. F6, F6, we go to this line, and when we go above, it will execute this line again, 30. If we click F8 or run, it will loop from this function back to the nearest breakpoint again. Breakpoint, breakpoint, F8, F8, and it will continuously change this number, because that's how the program works. Or you can just leave it at run and leave the program running. Let's remove this breakpoint and just leave the program running, and let's suspend it, and it probably did it very fast. You can see the value is already at 44,000. Let's run and pause, and the program is already at, now where it is, oh yeah, because that's a local variable, the variable watch changes depending on where you are. So in this case, we have stopped right in the middle of GPR.c library, or C executable, in the GPR toggle bits function. And yes, this is stopped, and it says the GPIO pin, which is this variable over here, has a value of, in particular, this. And we can go back to the main, go back to this line and say run to line, and bloop, it's gonna complete that function and return to here. We can add an expression over here and run it again, run again, run it again, run it again, and we'll increment. So that's how you can watch your variables without using your terminal like with RS-232. But if you want to print values, you can still use RS-232 or UART for printing if you need much more text. But in my case, if I have strings or something like that, I can just watch the pointers to the string, and it will also print the value of the string. So that works as well. And this video is 17 minutes long, which has to stop because I cannot make these videos that long. There's loads of function, and I encourage you to navigate through as many menus as you can, look at all the things, but this is the basics. You're gonna debug, you're gonna run. If I'm gonna go run, it will stop the debug session, or I have to stop it. So it's stopping the debug session and run, and this is the processor running this code without anything else. If you want to update this code, let's remove delay, Ctrl B for compiling, it finished. Run, so this is gonna push the code on the processor, and the LEDs are blinking on my board. So this is the debug window, and back to the coding window, which is very weird. It's like double, so let's just remove this console and debugger console, and that's more like it. I usually hide this window and have this one maybe very short because I have another window over here, but this is mostly what you're gonna do. If you have different boards, as you remember, when you create a new project, you just select another processor, another family, or another board. And that's it. I hope this helped you guys. This is, I think, is very simpler than the previous way that I did in my first video. But this is the more powerful, more efficient way of debugging your code and writing your code, because it's all in one package. And it's very useful when you have a larger code, when you have lots of functions and your code isn't working and you don't know why. With this, you can understand why the code is not working, where the code is going, where the program is heading. Is it heading where it should be heading? If not, you can see that by going step by step through the code. So from now on, I'll be using this template file, without this, of course. Or maybe, yeah, I'll leave this here so you can also always test if the board is working or if all the configurations are right. And from now on, everything we're gonna do is gonna be based in Eclipse, in this debugger, because it's just more efficient. If I learn more, I'll tell you more, I'll share it, and maybe through time I'll start learning HAL and make a series about that. So we're gonna transfer from standard peripheral to HAL. And after I understand that a bit, I'm gonna start a series and we go together again through it and make videos based on multiple things, so you will get all feeling for how the hull is working. So thank you again for watching this video, and I'll see you in the next one. Bye!